So welcome to the webinar. This one is all about high resolution cloud cost tracking and optimization with Seqera Platform. It's a mouthful, and I've got my colleague Rob Syme here with me, who is our scientific support lead, who's really the content expert and is going to take the lead on explaining this great content to you. I'm just going to MC for you. I'm the Chief of Commercial Partnerships here at Seqera Labs. And as I say, just acting as an MC and kind of keeping things moving through the slides. A little housekeeping before we get started. So you can use the Q&A to ask questions. Don't use the chat. So there is a separate section for Q&A. We're going to get to the Q&A at the end. We've got about 10 minutes carved out for that. So hopefully we'll have some really good discussion. There's a couple of polls near the end as well. We're going to run those, so please do participate in those. We're really interested in your feedback. And last but not least, we will be recording this and sharing it in a day or two once it's been produced. So we're happy to share that with you. Really quickly, I'm going to introduce our company, tell you what we're about. If you don't already know, I'm not going to spend a lot of time on that. And then I'm going to hand it over to Rob Syme, who's going to give you a little bit of presentation on the content, but also kind of interweave some demos in there so you can see sort of real world how you can save money with Seqera Platform. And then we'll get to the Q&A. Excuse me. So just a bit about Seqera. We started in 2013. Well, Nextflow started in 2013 at least. It was created by Paulo and Evan, our founders, and it very quickly took the market by storm in Europe and was really widely and quickly adopted, and then eventually crossed the pond and became very adopted in North America as well. At that same time, a little bit later, Phil and Alex started NF Core, which is a community of up to, I think, 10,000 people now, building pipelines, sharing modules, sharing best practices. And that community is a sort of adjunct community to Nextflow, and it's really successful and growing wildly as well. So hopefully you know something about that already. If not, definitely check it out. And then a year later, Seqera was founded by Paulo and Evan to provide commercial offerings, support, training, and eventually the Seqera Platform was born. And that's kind of the offering that we'll be demonstrating today. So that's kind of a little bit about the history. We've had some wild growth in the company. We have 2 million Nextflow executions happening each and every month, something we certainly didn't dream of 5 years ago to be hitting these numbers. We've got 125 commercial customers. I think 13 of the top 20 pharmas are our customers now. We've got some big government customers like CDC and Denmark National Genomics and Genomics England, lots and lots of research organizations and universities as well. We think there's over 100,000 scientists using Nextflow each and every day, and we have 10,000 users on our Seqera Cloud. So just some metrics on how things have gone on this wild ride since the early days of Nextflow and from 2013 to today. And you can see some of the customers and logos that we have on as commercial customers now at the bottom. A little vanity slide to brag about ourselves in a sense, but we're certainly happy and proud of those customers. Our mission is to advance science for everyone through software, and there's a number of ways we do that. So we've got really 3 pillars for that. There's open source software that we provide. There's the open science community that we participate in and we support, and all of you and many others participate in that community as well. And then there's the end-to-end platform. On the open source software side, it's really all about building, as you can see at the bottom. So you have Nextflow, which you're probably familiar with, for building and executing pipelines, bioinformatics pipelines and workflows for other needs as well. There's multi-QC for reporting on bioinformatics tooling. And then there's our new, maybe lesser known Wave product for augmenting and building containers. It's really cool and should check out. But these are sort of all open source, free to use, and in the build category. On the community side, I mean, we feel communities very, very central and important to our mission. Getting people using this software, getting people collaborating, working together outside of Seqera creates this engine and community and growth that we could never do on our own. And by getting hundreds of companies and tens of thousands of people building containers, building pipelines, adding to the documentation, collaborating within NF Core, we're just seeing this real groundswell of activity. And that's really driving the science. That's helping each other do more science, get to your scientific goals faster. And then the last pillar is our end-to-end platform and our commercial products that bring this all together and sit on top of the open source community and software to provide a commercial solution to allow you to scale your business to get to your scientific results faster. And those products are things like our Seqera platform, our Fusion file system for accelerating your IO into your pipeline so that you can get more done faster and save money. And now data studios to allow you to do tertiary analysis after your pipelines have run things like RF Studio or VS Code or Jupyter Notebooks, and do more than what you previously could achieve with the platform. So we're really excited about the growth and the breadth of the platform as we've launched these new products like data studios. As you know, this webinar is all about saving money. So just a few of the categories we think really will drive cost savings for you. And Rob's going to spend a lot more time drilling into each one of these and actually showing you in the product how this happens. But increasing savings, what it's all about. And if you're leveraging spot instances, you're going to save up to 90% of your costs, and that's a big driver. That's sort of the first thing we talk to customers about. Is make sure you're using spot instances, save money with the retries, with the pipelines. If those spot instances go away, you can still save money with the retry and start where you left off and get going again without losing any of your work. Improving throughput, we have a machine learning-based resource optimization tool that can analyze your pipelines after you've done a few runs. It'll tell you the optimal machines to run on. So if you're running on too big a machine with too little memory, it'll tell you this is how you should run your pipeline. You can optimize it. We've seen dramatic cost savings with that, up to 85% by optimizing the pipeline instance selection. Things like unnecessary runs. So we have labels, we have flexible search, pipeline resume functionality that can save money. And just probably most importantly, just providing visibility to what's happening so people can see the costs of what they're running, manage those costs, ensure they're staying within budget, and driving cost savings there. So lots and lots of ways we go about saving money. Fusion file system is a big one because it really accelerates the IO of your pipelines sitting on top of S3 in this case, or any object storage. Pipelines finish much faster. That means they're not staying in compute as long, and you're saving a lot of money on compute. So if you want to get results faster and save money on compute, then certainly Fusion file system is something to take a closer look at. So I'm going to leave it right here. I just wanted to kind of throw out some of the big buckets of cost savings that we're focused on. And I'm going to turn it over to Rob to take you through the slides and the demo.
Perfect. Thanks, Rob. I appreciate the introduction. It's a great introduction to Seqera and the sort of topics we're going to be talking about today. So first of all, it's fantastic to see so many people here. And it's great to see the interest in this particular topic. It's an important part of doing modern computational work is leveraging often cloud providers, and doing so efficiently is something that we feel quite strongly about here at Seqera. So I'm going to break this talk down into two halves. First, we're going to talk about how you might go about measuring those costs. So, for example, how there are features in the Seqera platform and in Nextflow that allow you to get better visibility into those cloud costs. And then in the second half, once we feel comfortable with how we're measuring that spend, we can talk about features in the platform that allow you to minimize that spend. Okay, so the first half, tracking. How do we associate resources or costs with particular teams or particular pipelines, or even finer resolution cost tracking? The first important part of cost tracking, and the easiest to implement, is compute environment resource labels. So each Seqera platform pipeline is associated with a particular compute environment. So if I switch across to the platform, I'll show you what I mean. So here I have the Seqera platform. I have a small workspace. I have a launch pad that has a single workflow, and every time I launch that workflow, if I view the workflow, I can see it's tied to a particular compute environment, a compute environment that I've called Spot. Here's Spot. And this compute environment, I've added here under resource labels some key value pairs. And each of these key value pairs will be attached to every piece of infrastructure that's spun up when I run jobs in this environment. these key value pairs are associated with the compute environment and are great for tracking teams. So for example, if we switch back to a sort of more diagrammatic view, you might have multiple compute environments in your Seqera platform installation, and each of those compute environments can have a key value, one or more key value tags, resource labels associated with that compute environment. And this means that every instance that gets spun up in that compute environment will have those tags associated. This is very simple to do. It works across cloud providers, AWS, GCP, and Azure. There are some specifics around AWS, and because a lot of our customers are on AWS, I'm going to do a little bit more of a deep dive onto how you might use those costings and tags in AWS. So there are three parts to Nextflow cost reporting on AWS Batch. Firstly, you set the tags. That is when you create the computing environment, you can set those resource labels. And then you're going to need to push at least one Nextflow run with those tags. This will send the tags to AWS Batch, and the jobs will be appropriately tagged. Once AWS has seen that key value pair, you will then need to activate the key value pair as a cost allocation tag. This flags to AWS that you'd like to track the costs associated with that key value, that key. And lastly, we're going to create a report. So the first is to set the tags. Let's actually give an example of that. We'll actually do it live. So I have a compute environment here. I have a compute environment's running on spot instances. Let's say I'd like to make a new compute environment. Maybe I want to make one that is on demand. And maybe I want to have two compute environments just to have the option to switch between them. I'm going to switch to use the Forge feature in Seqera Platform to build the infrastructure for me. And here I have my resource labels. So I'm going to say type equals on demand. And you might, for example, associate these with a particular project. And those key values will be associated with each instance. I'm going to click add. I think that should be enough. It will create the computer environment. And now any jobs that are launched inside of this computer environment will have those key value pairs attached. The second step, once we've created and set the tags in Seqera Platform, is to activate the tags. Again, now we just go to the AWS console. Under billings and payments, I'm going to move down to the cost allocation tags under cost organization. Here I have all of the tags that AWS has seen. I can search for the key that I'm interested in, for example, project. And then I just need to activate that tag. Once I've activated the tag, AWS will be tracking the usage of that tag, and I can use that tag inside of the Cost Explorer and, more importantly, data exports. So that's the last stage now of this three-stage process. We've set the tags in Seqera Platform. We've activated those tags in the billing and management, and that activation only needs to happen once. It's a one-off effort at the very beginning, and then you can sort of set it and forget it. The next stage is to create a report. Again, back in the billings and cost management on the AWS console, under data exports, it'll show all the reports you have available. If I want to create a new report, I can give it a name. I call it webinar example. And then under the options here, an important option here is the split cost allocation data. We're going to talk about that in a little bit more detail, but I just want you to remember that we've switched that on. I select to create these reports daily, and I choose Parquet or GZIP. I'd strongly recommend you use Parquet. Querying it with tools like DuckDB is a pleasure. And the last thing we need to do is to select a destination where AWS is going to write these reports. I'm going to put them in an existing bucket. You can create a new bucket if you want. It's got a policy that's going to be applied to that bucket, which is fine with me. I select that bucket, and I can optionally, if I'm generating multiple reports, I can give that a prefix. When I'm happy with that, I can create export, and that's going to give me a new data export report here. I can look inside of the bucket, or I can look at the details of this report. It's got a huge number of columns. This gives you lots of options for slicing and dicing the data, but included in those columns are those keys, those resource allocation tags that we selected earlier. At the moment, an important caveat to these reports is they're run and generated on a 24-hour cadence. So there's nothing reporting here, but if I had to check in tomorrow, I'll have the reports from any runs in this account. Okay, so adding the resource labels to the compute environment in Seqera Platform will allow me to track cloud spend per compute environment. And this is usually sufficient for managing groups. So you might have your oncology group or your sort of proteomics group, each with their own compute environments, and you can simply attach those tags to each compute environment. And then inside of the Cost Explorer or the those data exports, you'll be able to slice and dice the data to differentiate how much was spent on the oncology group versus the proteomics group. But what if we wanted to get a little bit more fine detail? What if we wanted to track costing per workflow or per run or even per task? What if I wanted to do some fine-grained benchmarking to really understand how the cloud spend, how the cloud is being used in my Nextflow runs? Well, the Seqera Platform does already offer an estimated cost. So if we look at one of the example runs, if we look at a run from the platform, you might already be familiar that there are these estimated costs. What I want to stress is this is an estimated cost, and this is an estimated cost that's updated in real time. We have an estimated cost for the run. We also, if you were to drill down to any of these tasks, have an estimated cost for just this one task. Again, this is an estimated cost, so it's worth understanding exactly how this estimate is generated. So let's say we have our compute environment A, and we've run a Nextflow run in this compute environment. My run has spawned 2 tasks, which are running inside of an EC2 instance. So these cost reportings are being measured by Nextflow. And at the moment, Nextflow looks at what percentage of the machine each task has consumed and the duration of that task. So for example, if this machine cost $10 to run for the duration from here to here, and this machine had 2 CPUs, for example, we're going to ignore memory for the moment, but it works in the same manner. Let's say this machine has 2 CPUs. I have one task which consumes 1 CPU for the full duration of the instance, and another task which consumes 1 CPU for short duration. What Nextflow will do is we'll say, okay, so the machine costs $10 to run, $10 per hour, and maybe it runs for an hour. This first bottom task here, we're going to assign that estimated cost of $5. And this smaller task maybe runs for a few minutes, and maybe, so we'll assign that a cost of, well, maybe runs for 10 minutes, and we'll assign it a cost of $1 as a fraction of the total runtime. So those 2 are summed up and allocated, and that cost estimate is reported back to the platform by Nextflow. The challenge is that it's difficult to do real-time. The challenge is that Nextflow doesn't know about any other runs that are happening concurrently on the same instance. The run doesn't know if there's another concurrent run that also happens to run tasks in the same instance. The current cost estimate takes the fraction of the machine each task is consuming and multiplies that fraction by the per hour instant cost and the job duration. So the cost estimates inside of the platform are great because they're fast and they're real time, but they don't really know about the total cost of the instance. We won't know that until the instance shuts down. So what if we wanted to trade off the real-time reporting for more precise cost tracking? And the reports that we generated, that I just showed you how to generate on the AWS console, have a much more expanded visibility relative to a single run. So those cost reports will know the total duration of the instance, the total cost of the duration, and all of the runs on it. So this is where this split cost allocation data that I pointed out when we created the report. If we click this checkbox here, what AWS will do is take the total cost of the instance, look at the tasks that ran on that instance. Let's say, for example, we have a total instance cost of $10, and we have these 3 tasks that run on that instance. Run A has a couple of tasks, one which consume half the machine for the full duration, and another task which consumes 1 CPU for a short duration. And then run B has a single task which consumes a single CPU for a moderate duration. What AWS will do when you click that split cost allocation data checkbox, it'll take the total cost of the instance and then weight that total cost by the resources consumed by each instance, or the resources requested by each task. So for example, we say of the green area here, run A consumes 80% of that area and run B consumes 20% of that area. It'll take that $10 total cost, and break it down. And inside of the cost report, you'll be able to see that Parquet file. You'll be able to see that the tag run A has been assigned $8 and run B has been assigned $2. So we have these 2 methods of measuring cost. One built into the platform, which is nice and quick. It's real time, but it is just an estimate. Usually an underestimate. It assumes optimal packing of the tasks. So that is great for quick and dirty checks. Maybe you want to switch tools and have a rough estimate about if that is going to make the run more expensive or if it's going to make the run cheaper. And then the second type of report are those cloud reports, the AWS usage reports that we generated inside of the AWS console. So those aren't real time. They're going to be published on a 24-hour delay, but we trade off that delay for more accurate costings because the reports know the full cost of the instance over the instance life. Okay, this is great, but what if we wanted even more fine-grained cost tracking? What if we wanted to track costings per workflow or per run or even per task? There's this very handy process directive inside of Nextflow called resource labels, and allows you to specify a map that is custom key name value pairs that Nextflow will apply to all of the resources in this run. This is the syntax for supplying this, but I'm also going to show you the syntax in Nextflow config. So let's say I have my run. I have my pipeline here. I'm going to edit my pipeline and apply some Nextflow configuration here. It's a small amount of config. I'm just going to paste it in here to prevent me making any typos. And we can share this. This is just an example. So here I'm setting the resource labels. It's a process directive, so it goes inside of the process scope here. And I'm assigning it a series of key value pairs. I'm assigning a unique run ID, which is the we're pulling from the Tower workflow ID environment variable. I'm also assigning keys for the process name, the tag, the container used, the run name, the session ID, and the pipeline name. You don't necessarily have to use all of these. And even this is a subset of the potential key value pairs that you could use. You could be even more fancy and assign key value pairs based on the metadata that's flowing through the process graph. But I think that's probably overkill for most people. Even this is probably more than most people will ever need. This is fine enough resolution. If I were to apply this configuration to my pipeline, when I run this, I can see, for example, here inside of configuration, I can see this resource labels configuration has been applied to my run. And if I look at one of the jobs inside of AWS Batch, I can see there's tags applied. So this is just one job, one task in Nextflow parlance. And I can see we've got a unique run ID. This 4CXM matches the run ID that you'll see in the URL on the Seqera platform. We have the run name, we have the process, we have the session ID and the commit ID. So we could then, in our reports, those Parquet files published to S3, drill down and see of the cloud spend, of the money I've spent this month, how much of it was spent running GTF filter, for example, or how much of my cloud spend was spent using the NF-core RNA-seq pipeline. So you can break it down by pipeline, by process, by sample, by repository, and so on and so forth. So you can get as fine-grained as you like. Okay, so that's the sort of first half. We've covered what we would do to sort of track and measure cost usage, either at the compute environment level, sort of the most coarse grain. That's very easy to do. You can just apply those key value pairs when you create the compute environment, and those will be reflected back in your usage reports on all the cloud platforms. If you wanted to be more specific, you can use those resource labels applied via configuration to the pipeline, and get very, very fine detailed cost trackings per process and per task. So now that we've got those measurements, each of the following points I'm going to make will be reflected in changes to those reports we've just created. So these are some tips that we've seen help people minimize costs on cloud platforms. The first is instance types, and I'm going to be a little bit specific to AWS here to save us jumping around too many cloud consoles. When you create a compute environment, I'd strongly recommend you consider the instance types you're providing. What we found, and this advice is very much workflow dependent. In fact, all of the advice I'm going to give for the rest of the webinar is very workflow dependent and sort of load dependent. But we've found when you create a compute environment, if you under instance types, it's helpful to select particular instance families. We have found, for example, in running the NF-core RNA-seq pipelines, and this is probably reflected in multiple pipelines, that the Intel family offer the best price to performance ratios of these instance types. So I can select the broad instance families here, and these will be sent to AWS when I create the compute environment as the potential families from which AWS can pull to run jobs. And we found that these instance types offer the best bang for your buck for most bioinformatics workflows. Of course, this is very much dependent on the particular tools you're running and the particular scale of data. The second advice I'd give is use spot instances, but I'm going to give, I mean, that's an obvious point, but I want to make some important caveats to that. Using spot instances is the most obvious way to cut cloud costs when running Nextflow. There are a couple of important things I'd like to point out though. Spot instances can be interrupted. Of course, that's the trade-off. We trade off the security of those instance lifetime for much cheaper prices. I would strongly recommend when you're running Nextflow, use these metrics table and check the job duration. In this particular small example, all of my tasks run very quickly in only a few minutes, so the chances of spot reclamation are very small. As the duration of each of these tasks increases, so does the likelihood of your instance being reclaimed. So if you have tasks that are running sort of 12, 24, 48 hours, like anything above sort of 18 hours or so, I'd strongly recommend you consider switching those tasks to run on on-demand queue. You might find, and this is definitely worth benchmarking using the cost tracking that we've seen in the first half of this webinar. It might be worth switching those to on-demand instances. If a job is being run on a spot instance and it's going to take 18 hours and is being reclaimed, Nextflow will resubmit that job, and there's a chance that you're just ending up burning money on those spot reclamations, just running the same task over and over again before it completes. So if you find that you have particularly long running tasks, here's how you would go about specifying that they should run on a different queue. You'll remember that earlier on in this webinar, I created a second queue here, an on-demand queue or on-demand compute environment. I can scroll down here and I can see that Nextflow has created for me this queue. This happens to be the same queue in both cases because it's an on-demand queue. It uses the on-demand compute environment. It uses the same queue for both the head and the compute. I'm going to copy that name. And let's say I would like to amend my pipeline. I saw that that star line was the longest running task. Let's say that it was taking hours to finish, and I was worried that it was being subject to spot reclamation. I'm going to edit this pipeline. And under Nextflow configuration, again, under the process directive, I'm going to specify a selector. So I'm going to say all the processes that have come from this star align process, I can redirect them to the star align, this on-demand queue. So now I have this sort of hybrid configuration where most of my processes and most of my tasks we're running on spot instances where I'm happy to take those cost savings because I know they're going to run very quickly. But the star align process, I've singled out as a potentially long-running process and a process or tasks that are at risk of spot reclamation. And I'm instead going to direct them to my new on-demand queue. If you wanted to be even more fancy, you could do something like task.attempt. If it's less than 2, I'm going to choose that spot queue. So I'm going to grab the queue name here. So this is a simple ternary expression. If on the first couple of attempts, if I'm just going to submit it to the spot queue, but if Nextflow is continually rerunning those tasks, I'm going to fail over into the on-demand queue. So this closure will be evaluated every time a task is submitted. And we have access to this task.attempt variable. And so basically, we'll try with spots a couple of times, and if it keeps on failing, we're going to force it and by scheduling it onto an on-demand queue. The other really important configuration variable is this aws.batch.max spot attempts equals 0. So the max spot attempts is on AWS, the number of times that AWS will internally retry spot reclamations. I think it's helpful to set this to 0. In fact, the new default is 0. This was changed in version 24.8 Edge. It used to be 5, it is now 0. So if you want to be specific, this will change the spot attempts to 0. So this means that AWS will not internally retry the job. It'll try it once. If the instance gets reclaimed, it'll push it back to Nextflow, and then your Nextflow will retry. So there are basically 2 retry mechanisms built in when you're on AWS batch. An internal one to AWS, which we're going to turn off here, and the Nextflow native retry mechanism, where we have a little bit more control. One of the really important ways we find customers are saving money is with the Fusion file system. The Fusion file system can be enabled easily. I'm just going to save that configuration. The Fusion file system can be easily enabled inside of a compute environment by simply enabling these toggles. So what is Fusion? Fusion is a file system that emulates a POSIX file system that's backed by blob storage. What is the problem Fusion's trying to solve? We found that a lot of Nextflow tasks began with staging in input data. So there might be large reference data files or large FASTQ files or just large pieces of data that need to be moved from blob storage in that task, that run work directory, that shared state, onto the virtual machine or onto the instance where the task is running. And for some tasks, that can be a considerable portion of time. You're just waiting till the instance spins up. Your cloud provider starts the clock on the costings. And the first thing the instance does is just copy in data from blob storage. Only when all of the input data is ready can Nextflow begin, and the task begins. Similarly, on the other side, when the task completes, all the CPUs spin down to 0, and then Nextflow will move the data back from the local machine back to blob storage. So basically, your task is bookended by these periods where you're just moving data around. The Nextflow file system shrinks those to 0 by basically or effectively symlinking in the data from blob storage. So rather than waiting for the data to stage, Nextflow creates what is like a link, and it streams the data in as the task is running. So rather than separating out your data movement with compute, those two tasks are overlaid, and you're computing on the data as it's streaming in. Similarly, as the task is writing data to what it thinks is a local file system, Fusion is streaming that out. And so we see significant savings. And I'm going to show you some of those in just a second. Essentially, Fusion cuts down the time that your instance is idly moving data around. The last and one of the more important cost savings is Groundswell. Groundswell is an automatic cost optimization feature built into the Seqera platform. So you might know that I can browse any run, and I can see here for any one task, in the metadata in this task table, I have the amount of CPUs and the memory that were requested by the task. What you might not know is that in the background, for every single task that Nextflow runs, Nextflow is measuring how much CPU is really being used by this task, how much of the 6 gig of RAM that I've asked for, how much is actually being used by the task. Those numbers are reported here and per task and graphically here. So I can see, for example, memory is a good one. Of the RAM that I've allocated, which are those processors that are only using a small amount of RAM, i.e., which are those processors where I'm essentially burning money. I could fit many more tasks. So for example, asked for much more RAM than I really need for these tasks. If this was a production scale data set, next time I ran, I would be well advised to reduce the amount of memory, like for example, the junction saturation tasks requesting. So I can use this plot here to manually go through and optimize the profile, optimize my pipeline by reducing the memory. That can be a little bit of a drain, a bit of a pain. Instead, I can use this optimize pipeline button here to have the platform do that automatically for me. The idea here is that you would take some production scale data set, you'd run it through your pipeline once, and as it's running through the pipeline, Nextflow is doing that work of measuring the CPU and the RAM usage for all of those tasks and optionally time. And then generating for you a sort of profile of what that production scale data set used for each of those tasks. So rather than relying on the defaults that are built into the workflow, I can now generate this optimized configuration which matches my data and sort of the size of data that I'm expecting. I can now take this optimized configuration, I can just copy paste it, I can check into version control with my workflow if I'd like. If I have authorship of the workflow, I can maybe, sensible thing might be to create a test or a optimized profile, a profile called optimized, and put this configuration under that profile. If I don't have control of the workflow, I could also just click save here. And now the Seqera platform will apply this optimized configuration to every single run of this NF-core RNA-seq pipeline in this workspace. So the idea is you take a production scale data set, use Groundswell to use Nextflow to measure the resources used by that pipeline and that production scale data set. And you can use this optimized pipeline button to generate an optimized configuration for your colleagues. So those are the important parts that I wanted to cover today. And I know this is a little bit AWS specific. Would be very keen to hear from you if you have if there's demand for GCP or Azure specific webinar as well. A lot of these are applicable to all platforms though. For example, this really important one, this compute environment resource labels, is applicable to all of the cloud platforms equally. So that's something you can do today. It requires very little effort and gives you cost tracking per compute environment. I'm going to pass it back to Rob Lalonde here to talk a little bit about the upcoming features or upcoming events we have at Seqera.
Yeah, hey folks. Thank you, Rob. That was excellent. Appreciate it. Got lots of questions in the queue for us for just a few moments from now as well. So yeah, on October 8th, we've got another webinar coming up. We've got a couple of our customers actually, Flagship is going to be on talking about leveraging somatic genomics for the development of transformative medicine. So I think that's going to be a really interesting and sort of on-the-ground science-y webinar. So I'm looking forward to that one. And then October 28th through 1st, if you can swing the travel, who doesn't want to go to Barcelona? Of course, we're going to have our Nextflow Summit in Barcelona. I think we've got about 175 people registered. We've got a great venue down on the water. And I think it's the lineup of speakers is phenomenal. So take a look at both of those at the URL there on screen on the events page. And if you're interested, we'd love to have you join us. The first poll should be popping up now on your screens, and it just asks if you'd be interested in a similar webinar for either GCP or Azure, or even we could do a custom session talking about that if you had a one-off request for Azure. And there's the poll now. Give you a second for that. You want to go to the next slide, Rob? Excellent. So we're into the Q&A. So I'm going to start at the top. So Daniel asked, after comparing cost estimates from Nextflow with real costs from AWS, as an example cloud, how accurate are their estimates in general?
Yeah, great question. So the cost estimates are really optimistic. They assume perfect packing of tasks. So they assume that any resources that are not used in the instance that have been packed by other jobs from other runs, which depending on the sort of scale you're operating at, can be wildly optimistic or moderately optimistic. So we find that if you're just doing small testing runs, you have a relatively empty compute environment. Like if you're doing benchmarking and you're the only one running in that compute environment, those cost estimates can be like a significant underestimate of the real costs because there's so much spare space. As you move towards production scale runs where you have lots of people submitting runs, there's a much higher likelihood of jobs packing in more optimally or more efficiently into those instances. And so as you move towards production, those cost estimates tend to reflect the real costs. But I do want to stress that they are just a cost estimate and they assume optimal packing. If you do want to do real benchmarking, I'd strongly recommend you use the cost allocation tags to do and just pull them out from the reports. If you're doing benchmarking, waiting a 24-hour cycle is a small price to pay for the accuracy that you'll get. So the short answer is they're an underestimate. They assume optimal packing, but as you move towards like heavy usage, those estimates become closer and closer to the real cost.
Awesome. Thanks, Rob. I saw a thumb up from somebody, so someone appreciated that answer. So Adam asks, will resource labels applied at submission be applied to all resources, including EC2 instances, et cetera? I was under the impression that only labels added at forge creation time will be applied to those resources.
It's a great question, Adam. Yeah, so by default, if you're on AWS, if you don't have that split cost allocation tracking enabled, then the tags will be passed on, but they won't be reflected in the cost explorer. It's only until you select that split cost allocation tags button, that one, this one here. So the tags will be passed on, even if you apply them at runtime, but they won't be reflected in the costing data until you click this button. Yeah, so those tags applied at CE creation time will always be unambiguously applied to all of the instances because it's a lot. there's no chance of collision. But those applied at runtime, there is a chance you might have a single instance, for example, that is running a task where project equals A and another task where project equals B. And so the instance won't have the tags applied because it's difficult to know which tag do you apply to the instance if two tasks are running as project equals A and project equals B. So the instance type won't get the tag, but because the ECS jobs and the AWS batch, the ECS tasks and the AWS batch jobs will have those tags, the cost explorer will do that work of taking the total cost of the instance and dividing it up among the jobs. So the short answer is, if you do it at submission time, the EC2 won't get tagged, but it doesn't matter if you have split cost allocation data enabled, because it will all come out in the cost reports.
Great. Stephen's got a question on spot reclamation. So he says, with your example of switching to an on-demand queue based on the number of attempts, is it possible to only trigger the switch to on-demand when the failure is due to spot reclamation, not failure for another reason?
It is a little bit challenging because if you have an exit status that you can pull, you have access to the exit status. You could probably do it, but it is a little bit challenging. Yes, so it's technically possible. You can use it. You just need a slightly more complicated closure.
Cool. Here's what I want you to take a crack at from Carlos. Can the streaming done in Fusion become a bottleneck for some processes?
Well, it's possible, yes. But generally, if there are a couple of ways to avoid that. The first is to set up to make sure that your compute and your data are living in the same region. That'll ensure that you have the maximum possible network throughput between the instance and the data. The second thing to do is to ensure that your instances have NVMe disks applied. Because Fusion will use those very fast disks essentially as a local cache. So the data is being streamed onto the disk just ahead of ideally just ahead of what is being read by the task. And so your task is actually reading the data off the NVMe disk. And similarly, the data is being written to the NVMe disk. Still, it is possible under particular situations, under particular IO loads, to become bottlenecked. But that's still a much better trade-off. Like the alternative is that you stage all of the data up front, which is a massive bottleneck that you will pay for all processes at all times. So like it might be a bottleneck, but you have to move the data at some point. So it's much more efficient to move it while you're computing rather than upfront as a big blocking operation.
Thanks, Rob. Mari asks, are there any resources that describe how to track Azure execution costs in a granular way, similar to what you showed for AWS?
Yeah, so I mean, we would consider running a webinar like this, maybe focused explicitly and specifically on AWS or on GCP. So if there's demand for that, we'll definitely do another one of these just focused on Azure.
Cool. For groundswell cost optimization, is it possible to select the production data sets used to optimize the configuration? That's from Joshua.
Yeah, great question. So when you're using this optimize pipeline button, you select the run. In this particular, I've only run, because I generated this pipeline for this webinar, I've only actually ever run this once. This is Dreamy Sacks. But if you would run this multiple times, you would have multiple runs to select from here. So you would select which of the runs you wanted to optimize on. So you push your production scale data set through one run, and then you select that run from this dropdown. So yes, you can select the production scale data set used.
Raul asks, I've noticed that AWS Batch does quite a bit of over provisioning when running our workflows. That's not good. Have you had any experience defining more fine-grained queues so jobs fit more tightly within the required resources?
Yeah, so it depends on the trade-offs. I've seen that a bit as well. It's difficult. We don't have a lot. There are a couple of allocation strategies that you can choose, and you can select the different allocation strategy when you are creating the compute environment. But the one that we applied by default is is almost certainly the correct one for 99% of people. Yeah. So you can select one of these allocation strategies, which will affect the instance types that are being provisioned. But if you're like these defaults of best fit progressive or spot price capacity optimized are almost certainly the correct choice for you. Under very specific circumstances, the others might be correct, but the defaults should be fine. So in which case, the only other alternative is to have a series of queues and series of compute environments with very like restricted instance types, and then you can direct it. The problem with that is that AWS will only give you 50 CEs per region. So depending on the scale of your operations, you might be eating in unnecessarily to those CEs. Of course, those queues and CEs can be shared across multiple workspaces. That's totally fine. And you'll just need a slightly more complex configuration option. You can use those closures like the ones I showed before for redirecting queues. And maybe you could, for each instance or each process, direct it to a particular queue that uses a compute environment with a particular set of instances. That said, it's a lot of sort of manually fitting around. It does make things a little bit more fragile. It's something really nice about having a compute environment that has a large array of different instance types. Because then if suddenly you find that you have a larger data set than you expected, it can sort of overflow and just pull larger instance types and you don't need to think about it. What I found is that human costs, like your bioinformaticians thinking about infrastructure, is a very expensive operation. So the less your bioinformaticians can have to think about infrastructure, the better. So for my money, I think it's better to have like a wide variety of instance types and let AWS select the instance types that fits. Sometimes you'll have, particularly if you're using spot price capacity optimized, you might get a larger instance than you expect, but because AWS chooses instances based on their spot pricing, it could be that a smaller instance wouldn't have been cost effective. It can sometimes be that larger instances are more cost effective because of fluctuations in spot price.
Great. So Kevin's asking us to describe a little bit more about the Fusion file system. Is it a method for pulling from an S3 bucket, or is it a separate store hosted at Seqera?
It's the former. So it's for pulling data from S3 buckets. So they're always your buckets, your data that you control. This is not data that's uploaded to Seqera. So it's just a more efficient way of interacting with your own existing infrastructure. It's a Fuse file system that's tailored specifically for efficiently dealing with Nextflow tasks where that data is hosted in blob storage. If you're interested, Kevin, shoot me an email afterwards. I'd be very happy to chat about it.
Rob, sorry, let me just look here for any other questions. So tracking Azure execution in the same granular way you showed with AWS is certainly possible, right? Adi was asking that one. I think that's a repeat from the chat as well. And then we've got one over here. I appreciate the Fusion cost savings are dependent on workload, but has Seqera done any benchmarking on popular Nextflow workflows?
Yeah, great question. So, yeah, and the caveat, the important caveat is that the performance of Fusion, in fact, all the recommendations I have provided here are very dependent on the particular workflows that you're running, their particular IO profiles. That said, like a lot of people are running common NF core workflows, and you think they're representative of the sort of workflows that people are doing in computational biology and with Nextflow. So we have a blog post that Rob is dropping in here. It's just dropped into the chat. Thanks, Rob. Which details some internal benchmarking that we've run using testful profiles of common NF core pipelines, specifically NF core RNA-seq.
Great. Yeah, that blog post should be helpful and cover off what you're looking for benchmarks. We're set there. I think we're getting close to the top of the hour, Rob, so we should move on from the questions. We did miss a few, unfortunately. We're sorry about that, but we will get back to you via email with any answers that we weren't able to get to during the session. So you can see now that the second poll is up. So if you'd like to reach out to us to get any more information, or if you're happy where you stand, then just let us know and we can wrap the poll up. Appreciate it. 10 seconds for that. And that brings us to the end of the webinar. Rob, you were great. The
Thanks, Rob.
audience was great because we got some really excellent questions and people seemed quite engaged. So we're excited about that. So let's keep the discussion going. If anyone wants to follow up with us, reach out, ask questions. We will be getting back to the questions we didn't answer. And we hope to see you again soon on another event, or maybe even in Barcelona and live.
Look forward to seeing some of you in person in Barcelona or Boston.
Yeah. Thanks, everyone. Have a great day.